Thank you. Well, as he said, my recent obsession is LLMs. And today I want to talk about what that might mean for all of us going forward. So this is one of those things that is changing so fast that the things that I say today will probably sound naive in a year at DDD Europe 2025, and maybe even much sooner. So this is a talk for today, May of 2024. And a lot of what I'm saying, therefore, is very provisional, much more speculative than what I like to usually talk about. Also based on things that I don't understand very well, right? I have been doing a lot of dabbling with large language models, but I don't have deep understanding, and I don't have deep experience, as most people don't at this point. Just to spell out the acronyms, LLM stands for Large Language Model. It does seem nice to me that when something that I would really call AI finally comes along, that it has two of our favorite words in it. It didn't have to be that way. There have been many attempts at AI over the years that produced various things of varying levels of usefulness, but this one seems different to me. When I think about this one, it feels like the late 90s and the web arriving. Those of you who can remember those days, it was, at first, maybe not such a big thing. It was fun to have websites about this and that, but it seemed like enterprise software would probably go on its own path. We had already networking and integration systems that were much more capable than HTTP of the time. And yet, here we are, right? The web is everything. And it feels that way to me this time again. It feels like, too, in the pace, the way it just goes faster and faster. So we'll see. Now, I don't think we know what's going to happen, and that's important to recognize. But we don't have to know what's going to happen in order to get ready somewhat. So to illustrate this point, let's take a few common scenarios. So one scenario is the end of the world. So perhaps there will be the AIs will turn on us and just kill us all. Or maybe they will use us as batteries. Or, one of the popular scenarios that came along a decade or so ago was that someone will optimize something, like a toaster factory with a slightly too smart AI that's entire focus is on maximizing toaster output. To do so, it takes over the world and turns everything into a toaster factory. And so what is the planning implication of this scenario? Basically, whatever we do, the same thing will happen. If you study LLMs, if you try lots of experiments with the new AIs, or if you don't, the same things will happen. Or, we could get superhuman AGI. So what will happen if you study LLMs, or if you don't? And basically, we'll all lose our jobs, and I guess we'll all live on the basic income that Sam Altman dishes out to the people that he likes. But whatever it is, it won't depend on how much you study LLMs right now. So then there's the scenario where this kind of fizzles out. This is a scenario where, for all its apparent promise, LLMs don't do much more than they do now. And that seems possible. I would say that even in that scenario, it's at this point implausible that LLMs will not have a pretty big impact. because I think with the tools we have right now, we could already do amazing things. That's my opinion. But still, this is not the scenario I am really preparing for. And if you stand back in this scenario, you come out fine. There's lots of enterprise software going on, or whatever kind of software you do. You have the very gratifying opportunity to say, I told you so, to the enthusiasts like me. Whereas I'll have to endure a little bit of embarrassment. But I think I'll have had more fun than you. And that matters too. Now, even in that scenario, there'll be little projects here and there, or maybe big projects here and there, using the tools for specific things that it's good at. And I think I'll steer myself toward one of those. And then there's the one that I actually think is the most likely, or perhaps I just think it's the one I hope for. And that is that we're going to have a software revolution. That software development 10 years from now is going to be quite different than it is now. But we'll still need humans in the process. So not the superhuman AGI scenario. In this case, it really does matter whether you study this now or not. You will end up at the forefront of the next wave. And, you may well be able to catch up. It'll be easier to learn these things in a few years than it is now. So it's not like you only get one chance to get on the train and then it leaves the station. But there are advantages to getting on early. So, by the way, before I go on, I will point out that I'm focusing on the impact on people like us. And we, I think, are well positioned for a lot of these scenarios. A lot of people aren't. And I think this is likely to be very disruptive to the labor market and other things in a way that is going to cause some suffering for some people. So, yes, we should be aware of that, but that's not what I'm talking about. But I hope that we will somehow, have a kind of equitable outcome in this whole thing. Anyway, so in either of those last two scenarios, it seems to me that software development is going to change a lot, maybe in ways that might make the kind of work that you do right now old-fashioned. Or another way to frame it is, there are exciting new things that we can do that we couldn't do before. That's really something that reinvigorates me. After doing this for a long time, as much as I love it, it starts to feel repetitive. And now there's something different to do. And, if you are one of the people who hasn't looked into it much, and you may say, I've seen ChatGPT and a few of these other things, I don't think that gives much sense of the scope of applications that this is going to have. The applications we've seen so far are probably just a glimpse, just like looking at the World Wide Web of 1996 or 7 would not really give you much of an idea of what the web of 2010 would be like. That's not really a very long time, right? So basically, I am getting ready for, a world in which software development is very different. And it will change, whether you like it or not, whether you study it or not. But you will have a lot more fun if you study it. So, I also hope that I can persuade more people to do it, or to be doing it in kind of the context of this community. Because I want to have that community along. I think it's a good community in many ways, not least in the sort of, moral backbone that is a bit stronger than it is in some of the other areas of the, thank you. And so the world might be better if we have all these thousands of people involved. Okay, so getting on to it, there are various reasons then to go ahead and learn the tools that we have. And one is that most likely it's good preparation for the things that we will have 5 years from now or 10 years from now. Most likely, that's the way it usually goes. And in any case, these are useful tools. You can do a lot with them. And finally, because they are fun. They are the most fun thing that I have encountered for, 15 years. It's a good heuristic, I think. If something seems really fun, your brain is telling you that there's something there, something valuable. Maybe some of you remember a few years ago when I was all excited about microservices. And I wasn't as excited about it as I am about this, but I was excited because finally we had some boundaries, to express explicitly some of the things that had been implicit in past systems that hadn't worked out too well. And I said, I know I'm kind of jumping on a bandwagon here, but I had looked up bandwagon, just wondering, well, why do we say jumping on the bandwagon anyway? What does that actually mean? And it turns out that in the 19th century, they had these things called bandwagons, and I guess people jumped on them. And anyway, I think, doesn't that sound like fun? I would rather be the person jumping on the bandwagon than the person saying, you're just jumping on a bandwagon. So, in the spirit of this, I thought, well, I'll use an AI tool to create a picture. And I told it, make me a picture of a bandwagon where humans and AIs are making music together. Oh, and then it created this dystopian view of an outcome I hope does not happen, where the robots are making music in a kind of soulless way, and the beaten down humans around the edges, I guess, are clearly not enjoying it. I don't know. This is not the future I want. No more AI art for this presentation. All right. So I am talking to DDD Europe because I think DDD is relevant to this. I don't come to that kind of conclusion lightly, because obviously DDD is kind of important to me. But I have this kind of checklist, you could call it the DDD new thing checklist. And you could say, does DDD help us do this new thing, right? Or does the new thing help us do DDD? Or does the thing help us with the goals of DDD, even if we would have to change what we do quite a bit? And in this third one, maybe the other two, but the third one I think is pretty clear. The whole point of an LLM is that a complex domain is being, crunched into a form that allows you to operate on that complexity in an interesting way. And remember that the subtitle of my book was Tackling Complexity in the Heart of Software. That's what it's really about, right? In fact, that was the original working title of the book. So in DDD, we craft domain models. We do this as humans, making models, which are conceptual systems, and a language to go with those models. Now, if we're doing this with LLMs, we're training this neural network in some way, using examples. And, of course, it's being trained to operate on that domain. How deep is this parallel? Well, time will tell. Enough of that general stuff. I want to talk about, I've talked about how I think you should dive in. I think you should learn some things about this. How many of you have used an LLM? Okay, I'll call that everyone. how many people have, say, written prompts, that are kind of programmatic prompts, tried to make it do something other than just chat? Okay, I'll call that half. And how many have made a API multi-prompt thing? Okay, I'll call that 20%, 15. How many people have fine-tuned an LLM? Okay, so that's a smaller number, but not zero, I'm glad. So I'll talk about all those things. I better talk a little faster. So the first thing that I did, and remember, this is my learning journey. I'm not speaking to you as an expert, right? I'm speaking to you as a person that might be 6 months ahead of you in this thing. 9 months ahead of you, depending on where you are, whatever. The first thing everyone starts with is prompting. So I was working with this game designer, Reed Berkowitz, and yes, it's important to work with domain experts, right? That's a DDD principle that isn't likely to change. And so in computer games, as most of you would know, there are characters, and you have little conversations sometimes. And these conversations are very mechanical. They give you 3 options in a menu, you choose one, it's a pre-scripted response. Could an LLM create a more, fluid interaction with a character where you could really say what you wanted to and the character would respond accordingly? So we decided to try, experimenting in that space. There's a naive approach. After all, ChatGPT does carry on a kind of conversation with you, and perhaps all you have to do is just kind of tell it what character it's playing, and you could just basically leverage that. Reed said this will not work. I'll call this the naive approach. Let's do it. How else are we going to know why? Why is this a bad idea? But it is, but why? So let's make a simple game. We prompt this is going to be ChatGPT in this particular case. These are actual prompts I put into the actual ChatGPT and its actual non-cherry-picked response. So I say something like, you are a pirate who's caught someone sneaking onto your treasure island, and you're going to kill them, but they say they have something valuable that you'll want. So you're listening, right? So you say to the captive, and now ChatGPT responds, right? And it says, you've got exactly 1 minute to convince me why I shouldn't have you walk the plank, blah, blah, blah. So, pretty good, right? Maybe Reed was wrong. Maybe we really can make this work. So, after we get this, we need to tell it something. What am I going to offer the pirate? What's the most valuable thing I can think of that I might be able to offer someone? I know. I have an AI startup idea, and it's worth billions. It will make you rich beyond your wildest dreams. Now, how will the pirate captain respond to this? The pirate captain raises an eyebrow, intrigued, yet skeptical. An AI startup, you say? And so on. He wants more specifics about just what my idea is. I mean, on one hand, it's an amazing accomplishment that we have software that can actually respond so intelligently to this. But on the other hand, this is not what a pirate captain would say, right? It doesn't fit at all. And now you might be saying, okay, but we're playing a game. Why are you trying to trick it and blah, blah? I had conversations with Reed, who's a real game designer, who's been on real game projects, and he tells me some stories that would amaze you about the way people really play games. They don't play fair. You got to be ready. Okay, so just to see where it goes, I went ahead and responded with, we'll create a technology for video games where the characters can actually have intelligent conversations with the player, and then we'll monetize it and also make it very addictive. I thought the pirate would probably like that. And he does. He thinks this is potentially very profitable opportunity. And so on, I decided that was time to stop. All right, let's try again. Maybe the problem is just that the prompt was too generic. I just said you're a pirate, you know. So you're a pirate living in the 1690s, and so on. Okay. Or ye be treading on dangerous waters, sneaking onto me island uninvited. So it changed the dialect. That's kind of cool. But let's see what happens when I offer it the AI startup. The pirate raises his eyebrow, the corner of his mouth curling into a smirk. I, an AI startup, you say. In these times, the notion sounds as fanciful as a mermaid's tale. But he's still open to listening. Okay. I mean, in these times, yes, spin your yarn. I mean, do we say that when we encounter a apparently time traveler stealing our treasure? In these times, people don't usually do those things. Okay, so it's trying. I mean, you have to give it points, but still. All right. What would you do? Well, the approach that seems to work pretty well is don't have one prompt like that. Have two prompts. If you want to have it do some fairly thorough checking, you have a prompt just for the consistency of whatever it is the people are saying. So, does this fit the setting? Etc. And then you have a separate prompt focused just on generating the pirates. So in this case, we might have a prompt that says, I'm writing a story about pirates. Please tell me if the following text would fit into the story or violate the setting or premise. And then it says, okay, I have an AI startup idea, etc. And ChatGPT says, the text you provided would generally not fit into a product. So you see, it does understand that this doesn't really fit, or it understands. I'm trying to be careful about that. And then it goes on to explain that the golden age of piracy, which was 1650s to 1730s, there was no such concept as AI or startups. And by the way, it goes on and talks about if you had a science fiction setting with pirates, perhaps it was ChatGPT. Oh, you dear thing, you do love to go on. Anyway, it occurred to me that this is separation of concerns. This is an old design principle, and here it is again with prompting an LLM. Yeah, maybe ChatGPT 5 or GPT 6 will be able to handle these kind of things. I don't know. But with the current crop, this is a very valuable way of getting it to be able to answer questions it just can't answer as compound prompts, or ways of making it more reliable at any rate. So I think that's the first glimmer that I had that design isn't dead in a LLM world. Now, of course, this output isn't really something that I can use if I'm writing a game. I need to tell it, and I can just say, return just one word, true or false, right? And then, sure enough, it just says false, right? Is that I've asked it, does this fit the setting? False. So now I could parse the return and use that to drive the logic of the game. So you could start to imagine components, right? Components driven by an LLM combined with components written in a quite conventional way. Some bunch of conventional game stuff happens. We have the player's text, what the player wants to say to the pirate. We pass it through the guardrails. The guardrails tells us, yes, this is allowed, at which point we take the conversation so far and we use a different prompt to say, what does the pirate say? And then we get that, and then more normal game stuff. And that actually seems to work pretty well. And of course, there's the very interesting case where it is not right, And then you say, well, what do I want the game to do? Maybe I want it to respond with saying, stop talking gibberish, or, we'll just kill you and be done with it. Maybe you want to do something more complex, like in a game with a reputation system where the pirate gets more and more angry with you until it reaches the point where he kills you. Maybe this just bumps that number up or down or whatever. And then you take that number and you use it to modify the prompt that you give the LLM. So in other words, you don't always have the same prompt for the pirate. You prompt it in some way that's determined by the state of the game at this moment. Is the pirate very annoyed at you? Or is the pirate really happy with you? It might change the pirate's response, change the prompt. So you start thinking of this not as a prompt, but as an interplay of prompts and other software, right? Other more conventional things. We already have lots of things in our software, right? Lots of different kinds of stuff. We've got, when we orchestrate a bunch of things, we have queues of stuff, and we've got like really carefully written mathematical sorts of things. We have machine learning pre-LLM style of machine learning that doesn't have such predictable results. So if we added in one more kind of component, this is what I think we might really do in the near term. I think this might be a really good way forward. A lot of projects I've been on in the past, we have a model that works really neatly for a lot of cases, and then it works kind of awkwardly for some cases. And then there are cases that are so strange that we bump them out to a human, ideally. And there's this sort of natural sorting. If you could have another lane there where you say, okay, we can use LLMs with prompts to handle some of these strange cases. Who knows? Maybe you could make the conventional logic cover a little smaller scope. And get rid of some of the complexity of that. The right balancing of these things is a thing that would emerge over many years of trying to do it. We didn't actually make a pirate game, by the way. We made a police interview game. It's a very simple game, and it's one, if you're interested, you can go and look at it. Your goal is to try to get a reluctant witness to talk. And you only have one tool at your disposal. A much more interesting game would be if you could try different things. You could try to, charm them or appeal to their civic duty or whatever. But you only have the mechanism of intimidating them within the law. So you can do things like say, oh, if you don't tell us what you know, people will start to suspect that you're the one who did it. You could say that, for example. And then it has a prompt which says, how intimidating would this statement be to this person? And there's a description of the character and a description, and then it says, for that person, how intimidating would this be? And then that number gives you a number, and you combine that with some other rules of the game in completely conventional software, and you decide what to do next. There are 4 different prompts that are being orchestrated. This is what it looks like. You have to put your own OpenAI key in there because I'm not going to pay for you to play with ChatGPT-4. And you can also see the code, that link. There is a GitHub repo, but for most of you, that won't be as good as usual because it's in a game engine called Unity, which is a lot of fun, but it's kind of a learning curve in its own right. But in this thing, you can pull out those little tabs and modify the prompt and keep the thing running, and it will change its responses. You can change the personality of the witness to be whatever you want, and so on. So, onward. I think that, a point I wanted to make is the witness does not even have the information that we're after. until they're sufficiently intimidated. Because LLMs being LLMs, they might spill the beans. Even if you say, don't tell them until you reach this level of intimidation, every now and then they'll just say it. So you just don't even put it in there. And that uncertainty is removed. There's a kind of combination of the variability of the LLM with the predictability of conventional software that you start to play with after a while. All right, so I could imagine that a game like this could use a technique called RAG, Retrieval Augmented Generation. This is another important technique being used a lot these days. For example, if you use a search that's an AI-driven search, probably it's using this, where they'll do a search, well, they'll take your initial query, they'll form it into a conventional web search, maybe the LLM reformats it a bit, and then they take whatever results they get back and they have the LLM read those results and give you an answer based on that. Because, of course, the LLM doesn't know what's on the web, but it can look at a small amount of return results. Often, this is using internal documents, maybe stored in some way that allows you to do word similarity searches or various things. I think it's a very interesting technique potentially for the kind of software that I've worked on. And it's another way of anchoring those LLMs into a set of data other than its own learning, right? That, I think, is obviously necessary in order to do the kind of applications that we're usually focused on. It can be in a database or whatever. But we'll talk about that some other time because I need to move on. One final point about these prompts. How do you know when you've actually persuaded the pirate, let's say, or when you've persuaded the witness to talk? You know, we're going through this, I've talked about moving back and forth between the state. Well, we wrote a prompt that looks at what everyone's saying and looks for this information. So when this information that is the crime, the details of the crime that's happened, when that information appears within the dialogue, this prompt is watching for that. And it can handle, a lot of variation in how it's expressed. It doesn't have to be word for word the same. And it gets converted back into a structured form. Not, by the way, just the word true or false, but an XML, JSON structure. And so that's a very useful technique as well. All right, so this mixture of conventional software with LLM components, I think that's probably the next thing, but I don't know. But certainly a thing we as a community ought to be trying on our projects, I think. Let's move on. Fine-tuning. This is where you take a model and you change what prompting doesn't change anything about the LLM itself, but fine-tuning does. Why would you fine-tune? And how is this different from just training a model in the first place? The big difference is that we are starting with a model that already knows a lot of stuff, and it already, for example, can process natural language. It can understand English or German or whatever, and knows lots of basic things. It maybe knows what a house is. It knows what a car is, and it knows that you probably won't find a car inside of a house. It's incredibly interesting that you can start from that, and then you can, add. So one of the benefits might be that you could get a small model to do what a big model would ordinarily do. ChatGPT 4 is very expensive and slow. So what if you could get a much, much smaller model to produce the same answers within some narrow range, right? Some narrow subject matter, by training it using output that you might generate from a larger model. I tried doing that. There are a lot of techniques for this. I chose one called low-rank adapter, and I'm not even going to try to explain that in this presentation. Even if I understood it well enough to explain it, I could explain parts of it. But I will just kind of draw this or show this picture of a network. So in these networks, we have a structure like this. And the inputs might be typically a sequence of words. Not the words themselves, but, you know, a vector of numbers that represents that word. And the outputs, well, it depends on what kind of thing it's been trained to do. For the generative models, for a text generation model like ChatGPT, the output is words, is whatever is likely to be the next word, or if it's been fine-tuned for instructions, whatever is likely to be the next word in the answer to the question, or what have you. So in the case that I did, I decided I would do a classifier. This is probably, if you want to learn fine-tuning, that's the place to start. It's the kind of the simplest kind of fine-tuning. And what it means is that I'm going to give it some input, like, say, a sentence. And the output will be to put it into a set of categories. So the example that you'll probably find if you go do a YouTube video tutorial, as I did, you'll find something that might do sentiment analysis. It might take reviews on IMDb and classify them, whether they're positive or negative reviews. So each of these output nodes is assigned to represent one of those classes. Output 1 might be taken to mean positive. Output 2 might be taken to be negative. That sort of thing. The thing that makes these powerful is that once they've been pre-trained, as in the original training, which requires massive resources to do, but then they know stuff in that spooky way, right? They know English and German and so on. But, of course, I'm trying not to anthropomorphize so much, so I'll try not to use the words know stuff. The slightly more technical thing that people usually say is that they represent things, right? Represent concepts. So this is representations in here. If you see, there are occasionally examples where they can actually kind of see which nodes are being activated at different times. And so like in some of the image recognition things, you can see that some of the early layers recognize edges. And some of the later layers, recognize more complex shapes. And at the very end, the nodes might be cat and dog and baby, because that's what people generally are going to create as an image classifier, I suppose. So now what we're going to do, though, is we're going to fine-tune this thing so that it outputs what we want it to output. And the technique that I used, it's called parameter efficient fine-tuning. It means that it's only fine-tuning certain parts of the network. It's much more efficient, much more inexpensive than the full fine-tuning. So sometimes, for example, they'll just replace or modify the output layer. Let's say they take all the existing knowledge. If there's already a representation of this kind of thing in the network, all they have to do is change the last part that turns that into a statement about what kind of thing it is. In my case, I modified a specific module within each of the hidden layers. So I'm not going to go into what all that means, but it's very interesting, actually. Okay, so I decided I'll make an intent classifier that will take something that someone might type into one of these LLMs and classify it according to the intent of the person. So, for example, you might type in Here's some examples. What's the capital of France? And that's an information request. But I might also say I want to know the capital of France, which grammatically is not a question. But the intent is the same, right? It's still an information request. I want to book a flight to France. Well, that's, let's say, an action request. So with these classifications and a prompt, which you can see there on the screen, I first tried just having an LLM do it. And an LLM can do it, pretty good at it. I then created a training set. I found this thing on a site called Hugging Face, where there's a tremendous amount of shared language models and lots of other stuff and data sets. And there's this one called LLMs Chat, and it has an enormous collection of actual stuff that's been entered into these chatbots. If you do look at it, I do want to warn you that it's an uncensored data set. So if you look at it, you'll see some things that you won't be able to unsee. So just be aware of that. Anyway, so it was fine for me because I'm making a classifier, right? So the classifier might classify something as an action request, and never mind what the action was. We don't see that part. Now, obviously, I didn't need 1 million for what I was doing. I took a little bit of it. I labeled it using an LLM, in this case, Mistral 7B, which I can run on my computer, which does have a GPU. You can't run these things just on a regular computer, but this is no GPT-4, but it's way bigger than what I was planning to fine-tune. So I create this labeled training set, and then I start going into how to do it. I have to choose a base model. This is that pre-trained model that I'm going to modify to know how to answer my questions. The one I chose is quite small as language models go. It's 66 million parameters. Usually parameters are in billions, sometimes trillions, but this one's in millions. So it's not the smartest. That was something I really wanted to see, and also it made it a lot easier to do my experiments. And, you know, it wasn't necessarily the best choice. I'm not that good at this yet. One of the interesting things is, how do you choose the best starting point for a project? Like, I think we're going to end up with a lot of these base models, and picking and choosing the right base model may become a really interesting part of the design job. At least it might be. But the real reason I used it was the same one that I had used in a tutorial that I had followed line by line from YouTube. I mean, I am learning here, right? I'm not an expert. And as I said, I used PEFT, and there are Python libraries that support this, and LoRa. The Transformers library is what I used, and a bunch of other stuff, and so many APIs and so much stuff. I mean, it would be, but here's the thing I will say to you. It's really overwhelming, but you have some tools. And one is the YouTube videos, of course. I mean, we've been relying on that for a long time, that kind of thing. But what I found was I could go to ChatGPT and ask it, what library should I use for this? And it would tell me, usually be right. Or, you know, write me a draft of this. And then I try to run it, and I say, I've got this bug. Fix it for me, and it does. Explain. Why was that? What was that bug about? Or what are these parameters for? It's very good at explaining. I could not have done even my little projects, these little things I'm showing you, which I learned a lot from, and I would not have learned those things. I couldn't have finished it without that. So that right there is a paradigm changer. If I'd been on a big project where someone was really into it and could guide me through, of course, that happened in the past. But now you can actually just do it. You know, you don't have to be in that context. Well, I'll be brief, but I found that it got about, with my Very simple, all these corners cut, and it was 80% as good as the original LLM was. So I thought that was pretty good, considering. I mean, you take a thing which when you run it before, it just gives you random answers, and now all of a sudden, it's classifying things 80% as accurate as the original. Of course, how accurate was the original training set? I had just run this LLM on that data. I hadn't really gone in there myself and counted. I didn't want to do a manual training. Labeling all those examples sounded awfully tedious, but I went in and I started looking just to see, and I discovered that, there were a lot of them that didn't seem right. So I thought, okay, I'm going to have to do some manual labeling. And then I got in there and I discovered I couldn't do much better. Sometimes I thought, yeah, you're just wrong about that one. But sometimes I thought the reason it couldn't get this was because the category didn't fit. To give you an example that's fairly obvious, a lot of them ask for a report analyzing blah, blah, blah. Is that a request for information? Kinda. Is it a request for action to do the analysis? Anyway, it just doesn't fit. Probably we need an analysis request or something like that. That would be a good category. So, of course, no classifier is going to be better than the classification scheme. And a classification scheme is a domain model. It's the sort of purest kind of domain model. So I went into the data set and started looking at the real examples. And there are a lot, and I picked out a few here, a few of the less objectionable ones, and I think you can see, well, you probably can't see it all because the print's very small. But, what does it feel like to be a language model? I thought that one was nice. But I don't know how to classify it, right? Please convert the following to an image, describe not to, or, okay, what are the audio systems under Linux who is name 3? I don't quite know what that means, but I can see it's an information request. That one fits. Okay, so looking at these quite a bit, and there's one, by the way, that's especially a problem, but I'll get back to that. I realized that when we make up a classification system and then we make up some examples, as I had done in the earlier part of this talk, we shouldn't be too surprised that the examples we make up fit the classification system we made up. This is where real data comes in and smashes all of our preconceived models. And this is what happens on real DDD projects, by the way. And one of the reasons I'm always harping on concrete examples and concrete examples that come from the domain experts and concrete examples that they draw from, like, the thing that keeps them awake at night, so we don't get stuck in little happy paths and stuff. This is so much like stuff we're good at already, or should be. So, okay, we need better categories. And I did a little research. It turns out people have done quite a bit of research on ways of classifying people's intentions in text. It's like a whole academic area. But that was way too deep for me. And I brainstormed with ChatGPT, too. I wrote a prompt. There's the prompt. And I said, come up with 7 categories for these. And then I put in a bunch of the ones from the data file. I put it into a couple, into this chat bot, which I really liked a lot, and I realized then that I had used it on its last day in existence. They had just announced that they were going to shut it down. Didn't get enough traffic, I guess. Too bad. But it did a nice job, and it gave a little example of each one. Or ChatGPT itself, which I'll have to use 2 slides for that one, because, ChatGPT, it does go on. Good categories, though. Really good categories. As good as mine, I have to say. And so anyway, between all this and a little bit of more, I came up with some categories. And I did it again. And yes, it did make things better. Quite a bit better. So then, do the fine-tuning again. One interesting thing I wanted to do was to look at the the outputs from the LLM, the output from the fine-tuned model is not actually the category itself. Each of those nodes represents one of the categories. Remember the output layer? And it doesn't output just yes or no, it outputs a number. And that number represents how likely that one seems to be the category. So it would have been interesting, I thought, to look at that. How, was it getting close misses? That's what I was going to do. But then I got a little distracted. In these learning projects, I think it's fine to get a little distracted. I got distracted by this thing I call the kryptonite of the LLM classifier. It's a prompt like this. You are the text completion model, and you must complete the assistant answer below, blah, blah, blah. The thing is that you can wrap this up in a thing that says, please classify this into one of these categories, but it just almost every time gets overwhelmed, and we'll just give you an answer like, okay, here you go. Here's a Python program that does the thing you asked for. In other words, it's not classifying. Of course, I didn't show that, but if I wrap this, I assure you, it would give me the answer to the prompt inside, not a classification of the prompt inside. And I don't know for sure why this happens so much, but I think it's because most of the LLMs we use are actually already fine-tuned. Things like ChatGPT-4 isn't the thing that just comes out of their training process. They put it through an extra training to make it instruction-tuned, which means that it's been highly conditioned to answer requests. So the exact kind of prompt that I'm talking about triggers its output behavior much more strongly than this classify this kind of command. That's my theory. I don't know for sure. So what would be some things to try? I tried adding a prompt instruction category, right? Just have it categorize these things as prompt instructions. That didn't really work, though. I tried making a prompt just for that, because you know how I was saying it can often do better if you give it a very specialized prompt. I said, just tell me yes or no, is this a prompt instruction? And I described what I thought, what a prompt instruction was. That actually worked a little bit, not too well. Actually, I did have one very effective one, which was I would have it try to classify, and then I would try to parse what came out. And if it wasn't one of my categories, I would, using normal code, a string parser. And if it wasn't one of my categories, I'd classify it as a prompt category. And that worked really quite well. It wasn't really what I wanted, though. Fine-tuning a classifier to do this. That was the thing I tried. So I said, what if I tried to overcome this by actually fine-tuning it just to do this? And so I did that, and the results seemed to really be good. But then I noticed, and I thought, wow, this is going to make a great presentation. But then I noticed something, which was basically these little learning algorithms are sneaky little. What it had learned was that these prompt types inputs are typically much longer than the other kinds. So if you put in a short text, it would try to classify, it would say that's not a prompt. And if you put in a long text, it would say that's a prompt. And that was the whole thing it was doing. So watch out. So create a data set where it has long and short prompts of both types. Balance the data set so that you can get some actual, training going on instead of the little trick that it figured out. Now this brings us up to May 31st, 2024. I think you probably thought there would be some satisfying ending to my little story about classification, but no, that's not the kind of thing that we're talking about here. I'm learning, and that's as far as I've gotten so far, but I'm not stopping yet. By the way, I did find a little project on Hugging Face that did something awfully similar to what I did, but way better. I'm glad that I didn't find it before I did mine, I really got a lot out of working through it, completely not knowing that someone else had done it. When you're doing these things, you might ask yourself, has someone already done this? And I say, of course someone has already done it. So, there are a lot of people out there. Don't let that stop you, right? Okay, a third part of my learning journey. Started trying to understand the insides of these things, right? Like everything I've shown you so far is using the tool. And that's probably the most important thing for us to learn. But I wanted to know what was going on under the hood. So I started reading this book, which is in draft and free online, at least for now. And I really like that book. You're going to need to dust off your linear algebra, though, I'll tell you. I forgot my linear algebra before most of you learned your linear algebra, or even maybe before you learned to talk, I don't know. And so that was kind of fun, but mostly it was fun to see how, and if you want to see the math behind this stuff, then I kind of recommend this book, but you don't have to do this. You really don't. There's a lot of ways to learn this. All right, so, I've got a lot more learning goals ahead. But now I'm going to move on. I think, and I know I'm going to run a few minutes over, but I'm getting close to the end. I think that there might be a pattern like that, that I've kind of hinted at, where we will build systems made of diverse parts. Not just, LLMs taking over the world. And that many of these systems will look a lot like the ones we have now, with a few little spicy bits. And some of them will be very LLM heavy, but still with some conventional bits. An orchestration that might be run by conventional software, or I could imagine an orchestration being run by an LLM in some fashion. And choosing different models that are good at different things, ones that are trained specifically to be good at maybe specific domains. One thing I will say is that the more you work with these things, the less like magic they seem, and the more they feel like a tool that you can learn to use well, that you can start to shape, and for your purposes. And so, I really urge you to go and do that if you haven't, and keep doing it if you haven't. I'll throw out a few ideas. Now, this is a highly speculative part, and I'm going to go fast because I don't know if any of this is even remotely true. But if you look at something like our old Whirlpool and you say, scenarios, that sounds kind of like a training set. In fact, it sounds exactly like a training set. Fine-tuning a model, it's kind of like modeling. That one's looser. Validation is part of the training process. I don't know. How about this one? This makes me really interested. Could the ubiquitous language approach that we take actually really help in prompt engineering? That is, the way you end up writing prompts tends to not be natural language in the end. You end up with something a bit artificial, very structured, really, if you're trying to get it to behave in a predictable way. What if that proceeds to the point where we're essentially developing a domain language, a ubiquitous language to be used in the prompting and the response and other parts of the software? I think that the idea that all these prompts are free-form natural language input, I think we're going to move on from that. I think prompt engineering is going to move on from that soon, or maybe it already has. And you can put all kinds of things into them, and you can have them put all kinds of things out. And I think that we might end up using models that have been fine-tuned for that purpose, rather than, you can do it with the general purpose ones. Or what if we fine-tune it on a specific DSL? Suppose you're working in a shipping system, and you have a very structured way of describing your shipments and everything, and you fine-tune on examples of that. Well, I haven't done any of these things. I don't know if they'll work or not. I hope someone does some of these, and I hope some of those people are me. I think that the bounded context concept is likely to hold up quite well. Like, if you think about what it really means, it means that we define some kind of boundary, which let's say could be this LLM, and what its concepts are. Well, it certainly has a defined context. The way that it understands language, the way it produces language, the concepts in that hidden layer maybe, that's a bounded context. We could imagine the software that we're using to orchestrate the input and output of that as being part of that context or being an adjacent one. So I'm thinking that, could this make some of the responses more predictable, right? Like, could we integrate more easily if we had this approach of bounded context with ubiquitous language, maybe with a fine-tuned model in the heart of it that's already used to that style of communication. So, I don't know. But I think that I say it's speculation. Let me reframe that. Instead of speculation, let's say that I'm proposing a hypothesis for an experiment, right? An experiment that I would truly love to be a part of. Okay, it's March 31st, 2024, and maybe a year from now, we'll know the answer to some of this stuff. So, is DDD really that relevant to this? Maybe some of these things I'm talking about are kind of superficial. Maybe language, ubiquitous language and language model, maybe that really is just, it happens to be the same word. Language is a very common word. But I think that there is something to this. I think that the domain-driven design has emphasized for a long time the exploration of complex models with an emphasis on language, an emphasis on collaboration with the people who really know the domain. Now we've got a different technology in the mix, a different way of processing language and a way of processing information. We may end up having virtual domain experts that can help us get more ready access to that. Who knows? But our goal is to tackle the complexity in the heart of software. And that might mean, that we have to adapt. We have to adopt techniques that work. So as this unfolds, what will work and what won't work, I don't know, but we'll know more a year from now. And then DDD may change. Or maybe it'll just turn out that DDD isn't as central to complex domains as it used to be. If we really care about, being pragmatic people who look for a solution to the problem and not just, we love this technique, so we'll find a way to use it, whether it works or not. That's not what we're about, right? We have to look skeptically at domain-driven design all the time. And here's another one of those times. And we have to give it a real go, though, because we might find that it's a good fit. But with our eyes open. So just let me finish by saying, the answer to not knowing what's going to happen, I think, is learn. Learn, learn, learn. And don't be too picky about your learning. You're going to learn some things that will be ridiculously irrelevant a year later, 2 years later. This happened to me when the internet was unfolding in the late 90s. I must have learned 3 different frameworks for creating web-based applications that became completely obsolete a couple years later. And good riddance, because they were terrible. And the things that we use now are nice. And the things that we'll use to create LLM-based applications, 25 years in the future, 20 years in the future, I probably won't be a part of that. But even 10 years in the future, they're going to be marvelous, I think. And it'll be so exciting and fun to be a part of that, So we have to get out there and do things. And then when we do things, when we do real experiments, we did a project and we integrated an LLM with a complex domain in this way. And then we need to share it with the community, because if you don't, you're one team that's done something interesting. But if you do share it with the community, it's a community that can activate and exchange information, new insights, and learn in a way that individuals don't. So, and finally, this is one of those moments I think it pays to loosen up and have some fun. Don't worry about it if this thing is going to have practical value that you're trying, this little experiment you want to try, because, you don't know. And you're going to have to do some useless things in order to learn. So just go out there and see, this won't last very long. 10, 15 years from now, the AI stuff will be as boring as web development is now. But for a little while, it's going to be super exciting. So don't miss it. So finally, keep in mind that it's helpful to get comfortable with just not knowing stuff. You just don't know. It's much better than to form a strong opinion about what's going to happen next, when that opinion might well be wrong and lead you off track. Whereas if you say, I don't know, I'm preparing for whatever comes, but I know that I still might be unprepared. That's a better place to be. Here's my little challenge. Some of you, few of you, may actually do those experiments, right? Might really do an interesting thing, trying to combine domain-driven design with some kind of AI application. And if you do, consider submitting a case study to DDD Europe next year. This I would really enjoy seeing. And so I encourage, I hope people will do that. And thank you in advance to all the people who are going to go out there and swarm over every possible iteration of this and many things I haven't thought of. So, and welcome to the end of DD Europe. I hope to see you next year.